Hello and welcome back to Exam Ignite. So this is a module 2, part 2 of the microcontroller BEC405A subject code for VTU 4th semester 2022 scheme. In this video, I'll be covering the remaining part of the module 2, that is commonly asked instructions in the questions in the exam. So here I'll be discussing the logical instruction and the stack subroutines with the examples. So this is a good marks and then highly expected topic where you will be asked with the questions like you have to check the validity of the instruction. To know that, you should know the concept clearly, like which is correct and which is wrong. So you will be expecting at least 1 or 2 questions directly from this part. So let's get started with this. Logic and logical instruction, we are having bit and byte level logical instruction. So byte level or the Boolean logic instruction. First we'll get started. We are having AND operation, which we use as ANL, OR operation for ORL, and EOR operation for XRL. Then AND. It is having a general format, that is ANL destination, source. This instruction will perform the AND on the two operands, that is place result in the destination. So destination is normally A. Source operand can use all the 4 addressing modes. So addressing AND operation is used to mask the certain bits. For example, we know the logical AND table. I have written here, this is our AND table. So move A, 35H and ANL A, 0FH. That is 35 first is written in the 8-bit and then 0FH is written in the 8-bit. So after writing that, you need to AND the each bit, that is 1 and 1 in the units, like 1 and 1 we will get 1, then 0 and 1 we get 0, 1 and 1 is 1, 0 and 1 is 0. Similarly 1 and 0 is 0, 1 and 0 is 0, 0 0 is 0. So this is my AND. Coming to the OR, I am having the format ORL destination, source. Here A is my destination. Let us consider the source may be any of the 4 addressing modes. Here I am using the immediate. Flags are not affected by the byte operand. This is my logical R table. Move A 04H, ORL A 30H. That is what 0 and this is 4. This is 30 and this is 0. So OR it now, you will get it as 34. Using the table, you OR it. Next is EOX or XOR operation, that is XRL destination, where destination is A. Source may use all the 4 addressing modes. So byte size operation, hence no flags are affected. This instruction is used to find the 2 registers having the same value. That is using JZ, and we make a decision, that is move A, that is ASH54H, and XRL, that is A78H. This is my 54, this is my 78, and using this table, just do the operation and you will get it as 2C. That will get stored in A. So XOR is used to clear the contents by XOR with the same content. So if we are having 45H and if they XOR with the 45, then we get the resulting as 0. That is what? 45, 45. 1 and 1 from the table is what? Here it is 0. So it comes 0. So next comes, we are using some other functions. CLRA. CLRA means it is clear the accumulator. It clears the contents of the accumulator that is registered to 0. That is A is what? 40H. Or else you can say is what? 00H. Next is CPLA. This is what? Complement the A. That is contents of A is logically complemented. See, for example, if we are having 40H, after the execution, 4 and this is 0. Write it as 8421. You can have to write it as 8421 and 4. You write in the 4 place it is 1 and here it is 0. So complement it. That is what 0 will become 1, 0 becomes 1, 0 becomes 1 and this 1 becomes 0. Now this value is this is my B. That is what 8 plus 2 plus 1. That is 8 plus 2 10 plus 1 11 is B. And then this is 8 plus 4, 12, 12 plus 2, 14, 14 plus 1 is 15. Next, swap A. Swap A means swaps the lower nipple with the higher nipple in the accumulator, according to the accumulator. That is, swap A means here you can observe 59 is there. Basically, it has to make 95. So before execution, it is 59. So after execution, write it as 5 and 9. So this comes here and this goes here, becomes 95. Next comes bit instruction. We learned about byte instruction now, bit instruction. CLC, see, this is what? Clear carry flag. That is, contents of the carry bit reset to 0. This instruction is used to reset a single bit in the port address. That is, P1 has the same some content, in that we select some bit to clear to 0. P1.2, second bit of the port content is reset to 0 by using the CLR P1.2 for clearing the carry flag. Next, SETB, set B, that is set the carry flag. Next, CPLC, complement the carry flag. That is, if it is 0, make it 1. If it is 1, make it 0. ANL means it is a logical hand with carry. That is ANL 1 bit, that is ANL ACC.3, that is for bit 3. Then A is 03 and CY is 0. Then you, after doing the AND operation, you'll get the value. Similarly, for the ORLC, that is what? With carry, do the OR operation. So next comes the RRA. Here, rotate the accumulator to right. 8 bit of the A register contents are rotated 1 bit to right. That is what? 0 in the 7th bit position. For example, let us consider 30H. This is my 3 and this is my 0. Now, I have to shift everything 1 bit right. When I shift it, what happens here is, this becomes 1 and here it becomes 8. So it is 18. A is 18. ARRC, that is what? Rotate A right through the carry flag. There is 8 bit in the A and carry flags are together rotated 1 bit to right. Bit 0 moves into carry and a carry content moves to the 7th position. For example, 31H. This is my 30 and 1 and I'm having an X. When I do a RRC, what happens after execution? This X will come to here and this 1 will move to carry flag and everything gets shifted 1 bit right. Next, RLA, this is rotate accumulator left. That is 8 bits in the accumulator rotated 1 bit to left. So bit 7 rotated into the bit 0 position. Like 31H, this is my 30 and this is my 1. So when I rotate it to left, what happens? 0 goes that side. So here it becomes 6 and this becomes to 62. RLCA, here rotate A left through the carry flag. So 8 bits in A and a carry flag together rotated 1 bit to left. So bit 7 moves to the carry and originally state of the carry moves into the bit 0 position. Like for example, this is my 30, 1H. Then what? This X moves here and sorry, I have written here 30. It is 31. So again it gets shifted. This X will go to the first one and finally you get it as 6 here. Next, the following types of instruction changes the program flow. Jump on bit condition here and compare the bit and jump if it is not equal. Decrement the bit if jump if 0. Jump unconditional. That is called a subroutine. Return from a subroutine. We'll start with the major instruction in the jump. First thing is A jump. This is what? Absolute jump. It transfers the program execution to the indicated address, that is 11 bit, and it is within the 00H to 07FFH. So L jump is the long jump. That is what? 3 bytes instruction. It is an unconditioned, there is no condition here, branch to indicate the address. So PC loads the 16-bit address to point the next instruction. This range is also same. Next is yes jump. It is short jump. It is relative address, it branches it is also an unconditional one. To address indicated, PC gets loaded to the relative address to final destination address. That is what we'll mention. PC is equal to the old PC plus the relative address word that gets added and the new PC is formed. Next, NOP, no operation. It is sometimes used for the timing delay. This instruction only updates the PC to point the next instruction following NOP. Next is jump and call instruction. Jump and call instruction change the flow of the program by changing the contents of the PC. That what jump means, it will permanently jump to that program flow, and it changes the program flow in the certain condition. If there is any condition mentioned, that gets executed. Call means it is a temporary change. So jump is permanent change, call is temporary change. So the program flow to allow another part of the program to run. So jump is of two types. One is conditional jump, another is unconditional jump. Condition means it will jump, which changes the program flow if there is only a certain condition exist. Unconditional means it changes the program flow irrespective of the condition. Condition there or not, it will change. So this range is from plus 127 bytes to minus 127 bytes. It is a 2-byte instruction. Then what? We'll come to the first one, JMP. At A plus DPTR means jump indirect relative to the DPTR. It is an unconditional jump because there is no condition here. The target address is obtained by total sum of this register and DPTR. It is a 1-byte register. Therefore, what? For example, A plus DPTR will get to the PC and that will be my new location. Note, you hear all the conditional jumps are the short jumps. That is plus 128 to minus 128 bytes. This is forward and backward. If more than minus 128 to plus 128, assembler gives an error message. Next comes JZ. This is a conditional jump. There should be a condition. So this jump is according to 0, branch to the next memory location, otherwise it will proceed to next instruction. For example, let us consider, first we will add what A comma R naught, they will get added. JZ, that is jump to the next. It's a loop, next. Increment R naught. Then what next is given here? Move A comma R7. If this condition is true, that is what? If jump is 0, that is if the condition is true, then it will come to the next. If it is false, it will move to the next this itself. So it depends on the condition. So next is J and Z. This is jump equal to 0. If this A and A are not, sum is 0, then it will go to the next. If it is not 0, it will directly go to increment R naught. Next is J and Z. Jump not equal to 0. If the jump is not equal to 0, then it will move to L1. If the jump is equal to 0, that is false, not equal to 0. That means equal to 0, then the PC will remain here itself. Next is, here you can see jump if accumulator is not 0, that is contents of A is not 0, then the PC will move to the next instruction specified in the relative address. Next is JC or JNC. Jump if there is a carry. Set PC branch to relative address specified within the instruction. Similarly, no carry means to the certain memory location. Let us see. If it is jump carry, if there is a carry, then it will go to my label loop and this gets executed. If it is false, the PC continues to the next instruction. Next, CJNZ. This is what? Compare jump not equal to 0. You have to compare and jump. If it is not equal to 0, then it will move to this loop. Compare these two and jump if it is not equal to 0. Or else stay back there itself. So here the destination and source may use 4 addressing modes. Anything can be used in this. And next comes DJ and set. Decrement and jump if not equal to 0. That is what destination comma relative address. This is a format. So decrements the value of the first operand, while decrement it checks whether the content is 0 or not. If not 0, then the PC will target the address specified within the instruction. Same thing. DJNZ, decrement and jump not equal to 0. If that is true, it will go to the loop L1. If it is false, then it continues with the PC. That is next instruction. Next is JB, that is jump. If direct bit set, if indicated bit is 1, jump to address indicated. Otherwise, proceed with the next instruction. So your jump if the accumulator with 0th bit position is 1 to the next memory location. Otherwise, proceed it with the same location. As it is true means it will move to the next loop, or else it will go to the PC itself. Similarly, jump not equal to B. If it is true, it will move to this next. If it is false, it will move to the PC. JPC means bit, comma, real. Jump if bit is set and clear bit. Jump if the desired bit is high and bit is clear to 0. If bit is low, then the PC will move to the next instruction. That's what same here. If it is true, it will move to the next instruction. If it is false, it will move to continuing. So this was all about my module 2, part 2 video. I hope all the instructions that I have explained is clear, and you can handle and get to know which is the correct instructions with full of confidence after hearing this. So I hope everything is clear. If this has helped you, like the video and share it with your friends, and do subscribe to the Exam Ignite for the next module, that is module 3, timer, counter and serial communication, where we'll simplify the concept and explain you the step by step. Thanks for watching till the end.